Hello everyone, this is Sam from HiPy. Today we're going to be learning about an introduction to machine learning. So no programming is going to be happening during this video. We're just going to talk about a very brief introduction about why you should be interested in machine learning, what it is, what libraries we'll be using, and kind of what's the difference between machine learning and other programming methods. So what is machine learning? Machine learning is a series of algorithms. It's sometimes called econometrics. It's sometimes called statistical learning, or like some other form of statistics, I guess, but it's about taking models with data. So we take a load of data in and we try and make sense of it in some way or another, and that might seem a little bit vague to you, and it kind of purposefully is, because machine learning is such a big kind of area of programming and in a way mathematics, that we kind of have to keep it a fuzzy definition, and we'll kind of see why later when I talk about examples. So there are two types of machine learning. There are supervised and unsupervised learning. So supervised learning is when we put in data, but then we also put in some information about the data. So we're telling our algorithm, here's the data, but here's also some kind of classification of what that kind of data is part of. So an example here would be if we had a load of data, and it was so we had all of our data, but alongside that data we had a list of whether each data point was red or blue, for example, or a fraudulent or a non-fraudulent transaction, or like a cat or a dog. There's loads of different examples here, but what the important thing is that our data is categorized in some manner, whereas in in unsupervised learning, sorry about that, the data is completely uncategorized. So we don't have any other information about the data points, and the computer just has to figure it out itself. So we'll be learning at some algorithms from both categories. We'll also be learning the weaknesses and strengths of each algorithm. So sometimes we'll know kind of like when to apply which one. And the main library we're going to be using here is scikit-learn. Later on in the neural networks, we'll be looking into other libraries such as TensorFlow and NLTK, but those will kind of like use a lot of the same philosophies and algorithms that the ones that we're going to be using in the following videos are. So the important thing to take away is kind of like the way of thinking about these and the way of problem solving. It's not kind of necessarily just solving problems. We want to be kind of taking away the frame of mind for these. And then the difference between machine learning and statistics. This is a question I get asked quite a lot when I was doing this, and the main one is that machine learning is used for building models that we're then going to use to do other things, mainly prediction, whereas statistics is used for, we take the data and we analyze it, and that's our takeaway. So, for example, in the regression, we'll have a video for regression and a guide for regression in machine learning and in statistics. In regression, we'll see that for statistics, we get a load of different outputs of a load of different nice analytical kind of variables and information that we need. But for machine learning, we're going to get out a model which we can very quickly use to plot and predict new points. And then finally, what kind of models is machine learning used for? Machine learning is used all the time in a load of different areas, because these algorithms are so abstract and the data points can represent so many different things. It's used in, for example, stuff like fraud detection for separating fraudulent and non-fraudulent transactions. It's used in IT services for Google when they want to recommend you different searches for the autocomplete results. It's used in image and pattern recognition. It's used in kind of criminal studies to do face detection. There's a load of different areas that this is used in, and hopefully through the mini projects throughout these guides you'll be able to kind of get a taste of what's going on. And the main thing I want you to take away from these guides and these videos is that these are a toolkit for you to use in your own problems and do whatever you need to do. They're not kind of a one problem kind of thing. There, we really want to kind of bring these to an abstract way of thinking so that we can reapply them to other areas. So we'll get started learning about different algorithms, and hopefully I'll see you in the next video.